Hello everyone, I am Surinder from 21MIS department. We are going to present on secure software development lifecycle. Let's move on to the points. Here we are going to say about see case studies. About first one is the Windows critical command bug, which is discovered very recently, like on 9th April. Second one is Cloudflare issue. And we are going to move on to secure SDLC and its overview. Now secure SDLC could have been prevented in this case studies that could have prevented these issues. And then finally and conclusion. Here this is a description, and then they are given and then the GitHub and the other site has been given this vulnerability at 10 out of 10 severity. But in my point of view, sanitization the user input is it's a developer's job, not a programmer language job. So it's not the fault of a language basically. Okay, let's move on to the description. It basically tells about Rust, and then the Rust library prior to 1.77.2 did not properly escape the arguments when invoking batch files with BAT and CMD executions on Windows using the command. An attacker will be able to control the arguments at the past. The spawn process could execute arbitrary shell commands by bypassing the escaping the severity of this vulnerability is critical for those who invoke batch file or Windows with untrusted arguments. No other platform or use is affected. So basically it's like some Rust code that's running on Windows PC that might end up interacting with some files and able to receive some kind of arbitrary user input. That user arbitrary remote execution could get an arbitrary remote code execution on this machine. Here you can see this is the batch file, and then this is the code. Here I got this from internet. Okay, let's move on. Here if you enter the payload, we are going to put it to test, and then you can see the string here entered is getting echoed out from using that bat command from that bat file. And then if you do it again, let's say if you type allow world now, it will give allow world. It will just run an allow world argument. Here he has been rendered a hello at the rate of mspaint.exe. Here that command literally had opened the MS Paint itself. So you can see this is kind of a severe bug. And then this thing you don't want some other bad guy executing a remote core on a machine now. It's worth noting that this bug is not something that you can just fix with some user input validation on the command that's being called, because the escaping is actually happening on the call that's being made on the batch file. It's not just a matter of poor implementation on the developer's end. It's also a vulnerability which requires an update, which Rust team has been put out. If you are running like Rust on Windows, you should update. And then you can see this is a command here, and then in this CV. Okay, so he has also used go, and then he has got this. He has asked about this system information, and then here the system information has been displayed. This is a very critical issue. And moving on, see here, yeah, system info exe, right? So again, it's not something you would want some random user to run on a machine and see this kind of information. So he also did the same on the Python. So he just taken a user input. It's using the subprocessor that are basically different libraries that these languages are using to interact with things like Windows command line. So you know that basically the system tools, right? So you have this Linux, you have this Mac and Windows and all. It would be convenient because it will be a bash script, but it will be like a bash script or something like that. You couldn't get a problem. Even in Mac, they also, I think they use bash. Here the problem really lies with cmd.exe. It gives arbitrary hello. If you add double extra code, that will give you an arbitrary remote execution, or guess in this case. Here I am doing just a local code execution. And then if I give this shutdown, here you can see here they are using a Python shutdown hyphen that yes, here they are saying if the disk gave shutdown now the computer will shut down. Again if we see here, if someone remotely the disk is pinned, it will become a big issue. Unlike most of the Windows application, this CMD is also blotted. So sometimes it's not only like Rust is a culprit here. Every programming languages can do this. Thing. Either it's with JS, PHP. We also saw the example of Go, and then Python. Every programming language can do this thing. I can kind of feel it is already have taken user input and just pass into the batch script that is the back end of the window. It's already pretty out there, but there's an application out there like Java. They literally said like we are not going to fix this bug because the sanitations that have been done from developer side, not this kind of from a programming side. So Java just refused to fix this bug. Here we can see Java won't fix. And then this command I have did it. This is a kind of an remote command, like very simple one. For an example, this remote command is deployed in a context where a user could remotely over a network as a part of a web application network service it could potentially introduce the security risks in such scenarios. If input validation sanitation measures are not being implemented, attackers could exploit a command injection vulnerability by crafting a malicious input payloads. To illustrate this, consider scenario where user input is required obtained from HTTP request in the web application, and this input is directly passed to a command execution function without proper validation or escaping. In such cases, attackers could necessarily send crafted HTTP requests containing malicious payload to exploit command injection vulnerabilities remotely. It's essential to implement robust security measures like input validation, sanitation, escaping, and then the exception handling like try and catch blocks, especially when processing user input in network vision application to mitigate the risk of remote command injections. Here this vulnerability is stated as 10 out of 10 like equivalent of to Linux command, the Linux vulnerability which has been discovered earlier. I think this vulnerability could have been like a Linux vulnerability should have been done like some security agencies who just wanted to infiltrate people's computer like that, but some intelligent Microsoft employees find it because he just saw a 500 ms delay while turning on this Linux. But these Microsoft developers like when the teams run like 20-second delay while opening, they don't care. But this employee saved like because of this 500 ms delay, he entered this employee has been noticed and then he has been running like different programs and has been find out that this has a serious backdoor issue, and then he informed it, and then he literally saved like most of the Linux systems on earth. This is about Linux. We just saw about Windows critical command back, and we also saw about some Linux things. Now we are moving to Cloudflare, and then Cloudflare is a cloud service. It has thousands of servers across the world in various points of presence or POPs, which nearby users send a web request to these servers are able to validate requests before forwarding to origin server. In Cloudflare case, security checks are used in the web application firewall software. Firewall rules are often configured using regular expressions with a part of strings or symbols, with each symbol represents a particular matchmaking instruction. Quick rejects rundown. Here we can see in July 2019, 27 minutes, this Cloudflare didn't work. So it's like most of the internet has been failed because they are using this Cloudflare cloud. And then we can see the culprit is here is rejects, and culprit began this is poorly written regular expression rejects within a WAF rule. Regular expressions are like powerful tools to find specific patterns within a text. Imagine security guard at the constant checking IDs or fake ones. Rejects act like this code's search criteria, a pattern that helps identify suspicious entries quickly. Here is a simplified example. The rejects .pdf would match all the files ending with .pdf. Example like report PDF or confidential PDF. However, in this case, a WAF rule contains a faulty rejects prone to excessive backtracking. Backtracking refers to the process where rejects keeps exploring different possibilities to match a pattern in a text. In Cloudflare scenario, a flawed rejects was designed to detect a malicious code injection attempts, XSS attacks. However, the way it was returned caused it to backtrack excessively, consuming an enormous amount of CPU resources significantly, causing to slow down the Cloudflare system. Imagine like security guard here is like here you saw the security guard example of checking the ID cards. Here you can also see this because of the faulty rejects one. We can take example security guard, and if a security guard take too much time checking, in the concept too much queue will come. The same way has been happened due to this faulty rejects command return to find XSS attacks. this entire thing got started to use more amount of CPU resources, and then finally the entire thing got crashed. Sequence of event. So we can see this is a sequence of events here. You can see the change has been introduced. An engineer implemented new WF rule containing the problematic rejects. This change aimed to improve Cloudflare's ability to block and detect excessive attacks. I mean like cross scripting attacks. Testing ourselves. Testing standard procedure failed to identify excessive CPU usage caused by the faulty rejects. The existing test likely focus on functionality and then missed performance implications. How efficiently the rule processed the data. It's like a security guard manager only checking the guard catching the fake IDs, not noticing the long wait times. Yeah, here we can see that because of this rejects fault, too much of CPU resource has been consumed, and then the thing finally got crashed. Fast rollout. Due to the need to respond rapidly to emerging threats, WAF rule deployments bypass the usual stage rollout process, going global instantaneously. This means new role with problematic rejects wasn't tested on a smaller scale before, like pushing out to all of the cloud servers worldwide. The first thing means we should test on a small scale and then we should implement on a large scale. But here they directly implemented worldwide. So you can see some engineer like finish this right, and then he submit a pull request to bit bucket request. Then as a part of a pull request, teams the continuous requirement deployment platform ran all these tests, and then giving the request confidence that the code he wrote wasn't last on the garbage. You can see a team sitting integration for bit bucket. And then others and team looked and then they also felt good to it. After this, Team City automatically built a tested a package once more, generated change request. After this request was approved by a manager or tech lead, a change will automatically deploy. This plan was to release in simulate mode where customer traffic is in block, but metrics should be collected by engineers to analyze effectiveness. You can see a WAF minor release. Yeah, after a bug has been released in seconds, attacking affecting our Cloudflare service due to CPU overload. Excessive black tracking has been triggered by faulty rejects, resulting in high CPU usage, and then leaving them with no resources to handle regular traffic. This ultimately brought Cloudflare core functionality, proxy CDN WF halt to halt. Here things went wrong because of the buggy redux and incomplete testing and fast rollout for non-critical users. Here, after as an aftermath, Cloudflare took swift actions to address these things. And then they also introduced enhanced testing methods, SafeWare rejects and then rejects in the remediation. Here we can see here you can see deployed animal colors, and I will be like two colors. One is a dog pop and then pig pop. Pig pop is for non-premium users. Dog is for paid users. Here you can see here this flowchart. After 3 minutes later, engineers paged for WF files. They thought this is kind of a hacker attack, and they declared a severe zero incident and escalated quickly. Many of users got affected, but after a few minutes, after a few minutes, they discovered this is a WF problem, not a global hacking attack. And then after 20 minutes, they from the request from the higher ones, they started a global termination, and they brought entire this Cloudflare thing to halt. And after 27 minutes, they fixed everything, and then Cloudflare started working normally. And the next slide, you can see this thing. Yeah, this part of the code, this is a culprit one. Yeah, this one. You can see this thing, some basic rejects output and input things. Yeah, and then this is the culprit. Okay, so this is a faulty line of code, and then we can see all these things happen because all these things wouldn't have been happened if secure software development lifecycle has been implemented properly. Secure software development lifecycle is a framework that helps organizations to develop secure software applications. It's a systematic process that integrates security considerations throughout the entire development lifecycle, from planning, design to deployment and maintenance. Here are the key steps involved in secure SDLC: planning and requirements. Security requirements are identified and documented along functional requirements. This stage involves them threat model to identify potential vulnerabilities and how to mitigate them. Secure coding practices are defined as part of a development guidelines. Design. System architecture is reviewed for security weakness. Secure coding principles are followed in design phase, such as proper input validation, error handling, etc. Secure libraries and framework has been chosen for development. And then the third one is development code and implementation. Developers follow secure coding practices to minimize vulnerabilities like SQL injection, etc. Static code analysis tools are used to identify potential security flaws in the code. Unit tests with security considerations are conducted to ensure the code functions securely. Testing 1. Security testing goes beyond functional testing. Tools like penetration testing are used to stimulate real-world attacks and exploit vulnerabilities. Security testing is performed throughout a life cycle, not just at the end. Deployment. Secure deployment practices are followed, such as proper configuration management and access controls. Vulnerability scanning is performed on a deployed application to identify remaining weakness. And you can move on to the next point. This maintenance and monitoring, regular security patching and updates are applied to address newly discovered vulnerabilities. Security monitoring tools are used to detect and respond potential security incidents. And then you can see here like what's the benefit of using the secure SDLC. This secure SDLC reduces the risk of security vulnerabilities in the software, protects the user data and system resources, improves overall software quality and reliability, lowers the cost of fixing security issues later in the development process. Additional consideration, you can see like continuous integration and development pipelines can be integrated with security testing tools for more faster and more secure deployments. And then you can see like security SDLC practices can be adapted to different software development methodologies like Agile or Waterfall. And then this SDLC, secure SDLC can reduce the risk of security vulnerabilities in software application. This not only protects the users and data, but also improves the overall reliability of the software. We can see, as you can see in this, we can see in for Windows critical command bug. Here you can see for preventing this Windows command injection vulnerability and secure software development cycle could have been implemented with following steps. Requirement analysis. Define security requirements like specifying proper validation sanitation of user inputs to prevent command injection. Threat modeling. Identify command injection as a potential attack vector and prioritize security controls accordingly. In design phase, design a secure architecture, avoiding solution equal to true in subprocess calls and preferring direct invocation of executables or secure AS. Implementation. Follow secure coding practices including implement validation, sanitation and proper escaping of user inputs. Testing. Conduct security testing including static test code analysis, dynamic application security testing and penetration testing to mitigate vulnerabilities. And in case of deployment, implement secure deployment practices, configure servers with principal least privilege, and apply security updates accordingly regularly. And then we should implement a monitor and login mechanism to detect and respond security incidents, including command injection attacks. And we should give education training for stakeholders and developers, and to execute them with common security vulnerabilities and best practices for secure coding. And then in this case of this Cloudflare, here we can see the early warnings in threat modeling. During the planning stage, threat modeling could have been identified the potential for a poorly written rejects or consuming excessive CPU resources, leading to a DOS attack on Cloudflare infrastructure. This could have been emphasized for a need of performance testing alongside functional testing for WF rules. Code review. Code review process during design and development phase could have been specifically focused on performance implications of WF rules, including scrutinizing the complexity of reject patterns. Additionally, using well-established document that reject libraries could have prevented the potential issues arising from custom crafted patterns. Safety during development. Static code analysis. Static code analysis tools configured to identify potential performance bottlenecks that could have been flagged complex reject patterns within WF rules. This could have prompted developers to optimize pattern before development. Unit test with CPU usage measurement. Unit test specifically designed to CPU usage during WF rule execution could have been prevented excessive resource consumption early on. You can see this performance testing stage rollouts starting from smaller portion to the entire world. They should be staged. They should have been pushed on the stage rollout, so that we can see if anything faulty means you can only shut down a server instead of shut down the entire whole server. And then also they can see the importance of having a rollback mechanism. Having a rollback mechanism in place could have allowed roll for to quickly revert to the previous stable version of WF role if new one cause problems. And then you can see here security awareness, importance of security awareness training and a peer code reviews with performance expertise. And then the performance testings. Like here we have seen about how STLC could have been implemented in this Cloudflare and in this Windows, which could have been prevented this kind of attacks, ensuring the reliability. And then we can finally move on to this conclusion one. And then this Cloudflare, Windows and all, we can serve as a powerful case study for the necessity of secure software development lifecycle. A single faulty injects may seem like a minor issue. Its impact on critical services like Cloudflare demonstrate a cascading consequences of security vulnerabilities. A robust secure SDLC offers a multi-layer defense against vulnerabilities by integrating the security considerations throughout the entire development lifecycle, from planning to development, deployment and maintenance. Organizations can significantly reduce the risk of security breaches and outages. A secure SDLC doesn't guarantee complete immunity to security issues. However, by integrating these practices throughout the development life cycle, organizations can significantly improve the chances of catching and mitigating problems before they cause widespread disruption. By incorporating this, it can save time, money, resources, labor, and then company reputation, stakeholders trust, and also enhancing reliability of efficiency of the system before they cause some widespread disruption like this Windows command bug. In today's ever-evolving threat landscape, a secure STLC is not just an option but a necessity for building a secure, reliable, and trustworthy software application. Thank you.